So this is the Linux user group, and today we talk about Linux, internet, servers, ports, and firewalls. So Linux is a free and open source operating system. It was written by Linus Torvalds in 1991, and since then it's been community developed, and it's become the most popular server operating system. And it runs more than 95% of the world's fastest 500 supercomputers. And it's the leader in cloud computing of today versus and it runs on almost every embedded device on the planet, like Android phones and tablets, network routers, and smart TVs. So the reason Linux is so popular is the reduced operating system cost. It's free, and since it's open source, you and people constantly make changes to it. You get more performance and stability. It's more secure, and it's more customizable to your needs. So for embedded systems, you can adapt it to your device. It's good quality stuff. It's not just random people all over the world. Now the internet is a network of computers all over the world, and the most commonly used things on the internet are the World Wide Web and email and peer-to-peer stuff like file sharing. But most services use the client-server model, especially the World Wide Web and email. They both work on the client-server model.
If you install a web server like Apache,
going on in that case. But in a client-server model, you have a client computer which sends a request to a web server, which sends an appropriate response back to the clients, and it all travels through the internet, all this communication. So internet addressing, I'll compare it to the postal address system to make things a little clear. So a domain name is like google.com. That's like the name of a building. So let's say you say Centennial Court, it's a building that I know of, right? IP address is the building's actual street address. So it will be maybe 200 Mitchell Street or something. I'm sorry, a building's, yeah, and an IP address is usually a set of 4 numbers. So you must have seen IP addresses all the time, right? And the protocol, it's like a virtual sub-address within that, for that. So the IP address points to a machine, and the port points to a virtual endpoint inside that machine, and it's like an apartment number inside a building. So the domain name is a well-known registered name for a website. So google.com, yahoo.com, these are all registered domain names. And like you said, you cannot just pick a name, you have to pay for it. So there are registration agencies. You have to pay as much as like from $10 a month to $10 a year to $30 a year to reserve a name for you. And they and then when you run a server, you have an IP address. Their DNS service will map that name to that IP address.
okay, and so that's pretty much just like like Google.com is just like a huge computer that we're trying to connect to.
Yeah, it's going to be a whole bunch of so for a larger website, it's usually multiple IP addresses. They are running multiple servers at different locations because they want to speed up access to their website. So in every geographical region, they're running a copy of their web server, and anytime somebody requests google.com, they automatically look up the closest one and send you that address. But for smaller websites, it's usually a single IP. So if I'm running a personal website, it'll just be a single one-to-one mapping. And so DNS service is just like Yellow Pages. So if you look up, so the name of this building is ERB. That's what everybody knows it by. And if you want the street address, you'll look up the Yellow Pages or some directory. So DNS works just like that. Now, one web server, so a server is a machine connected to the internet. Now it could be running more than one service at the same time. So it could be offering both the web page service and an email service. But we talked about ports. So the World Wide Web Service is offered through port 80, and the email service is served through port 25. And so ports are a virtual concept. So when you plug in a cable to your computer, you are getting an IP address for that computer. You're not getting a port. So ports are virtual connection endpoints in your computer, and that helps keep data separated. So it'll keep the worldwide, the HTTP traffic separate from the email traffic. Okay, I will talk about that too. So again, back to the postal example. So in this building there are two departments, bioengineering and CSE. And bioengineering is operating from the second floor, CSE is operating from the sixth floor. So that's like port numbers on a computer. So by looking at the floor number, you can direct traffic mail to the correct department. So what makes a server different from a normal computer? A server is running a special program to handle user requests. So if you want to run a web server, you will be running a program called Apache or Nginx, which run all the time, and they listen to port 80 because that's the standard port for HTTP. So it's always running, it's always listening for data on that connection. Email programs like SendMail, they listen on port 25. And that's how a single website is able to, a web server is able to do multiple things. It can do web, it can do email, it can do many things. So on the client, like on our laptops, on our personal computers, we run client software. So for accessing the World Wide Web, we use a web browser like Firefox, Chrome, Opera, and email clients like Thunderbird or Outlook. So for every new connection, the client has to use a new port, a fresh port, and it cannot use one of those standard ports, right? Because those are reserved. So it picks a random number beyond 1024, any random number, because an outgoing connection must also have a port number. So incoming connections need a port number and outgoing connections need a port number. So it'll randomly pick a port and it'll transmit data from that port to port 80 of the web server, because the web server is always listening on port 80, the google.com web server. So my local port might be 5357, but that connects to port 80 of the web server. Same thing for email. The email program will use a different random port, but it will connect to port 25 of the email server. So this lets multiple connections to occur in parallel. And the server, it responds to the same port from which the request came. So if the request came from port 5357 for a web page, it will send the web page back to the same port. This is a figure explaining the same thing. So if I open Firefox and one tab accesses google.com, so since it's a new connection, it will randomly pick a port number and connect to port 80 of google.com. If I open another tab and I access yahoo.com, it will again open a random port and connect to port 80 of yahoo.com servers. And if I'm trying to send an email, again another random port, but connected to port 25 of the email server. So the client is able to handle multiple connections because of using ports, and the data doesn't get mixed up. That's the advantage. So Linux, as we said, it's very popular as a web server. Why? Because it's robust, it's become really stable that you can run it for 24/7. So I have a Linux machine in my lab that's been running for 133 days. Today I checked the uptime, and it's never crashed and nothing's wrong with it. So, and the other reason is it's free, and there is a bunch of free software that integrates really well and lets you serve very complex websites. So google.com, it needs HTML, it needs dynamic pages, it needs databases. So we have free web servers like Apache, Nginx. We have PHP available for free. We have MySQL for databases. So it makes a very good combination that's free.
Is MySQL free?
Yes. So if you want to set up a basic static website, like you said, all you need to do on a Linux computer is install either the Apache 2 or the Nginx package, and just go through the configuration if you see if there is anything to be configured. But the default installs of both of these are good enough. They work out of the box, but you can still take a look, and then save your web content in the designated folder. So the website that's supposed to be sent to clients requesting the website, those files need to be at a particular location, and that's determined by the configuration. And once you've this set up and running, you can give your IP address to other people, and they can just type in the IP address in the web browser, and they'll see your website. So I'll try to.
Are there any significant differences between Apache and?
Yeah, so Apache is a very old and robust system, and Nginx is new, but it's optimized for size and speed. It can serve smaller websites, but a bigger website which will have millions of users and millions of threads. So as the number of parallel users grows, the program needs to be stable enough to handle all of that. So Apache is good at that, but it can be slow and it will use a lot of your memory. But Nginx is very small and runs quickly, but it cannot handle too much traffic. So for smaller websites, people have started adopting that one. That's the thing. So if I wanted to install Apache on my machine, I just say sudo on Ubuntu or a Debian machine. This is the command apt-get install. So the package's name is Apache 2, and I already have it installed, so it won't do anything. And then it says look at the configuration files, but like I said, the configuration is all set. You don't need to do anything. You can just, one thing to know is that Apache needs all the files to be in this folder /var/www. So this particular location is the default location for Apache web pages. So if I look for the files in this folder,
You have 4 W's.
yeah, so it's 3 W's, and so I have an index.html. That's the default page a web server returns when you type in the website. So in my web browser, and just to make sure that Apache is running, I'll say sudo service apache 2 start. So it's probably already running, so nothing happened. But I can go here and I can type. So if you're running, if you're trying to access a service on your own machine, you have to use the address called localhost. So I'll say localhost, and this is the default web page served by this web server. So this is making a request to my local web server, and the server is returning this page. So I have another page saved at that location. So what this means is you can add content to that folder, and that will show up here. So I called it new index.html. So that's another page that I wrote. So this is being served from my laptop running Apache.
How did you write stuff? How did you do that?
So this is in this sense, so I said all the content needs to be in this /var/www folder, right? So I created a file new index.html, or I can just replace the old one. Eventually you will want to replace the old one.
Okay.
And you can just write some HTML code inside that page. So a very simple HTML page, and I have an image file there that shows up. So that's all you need to do to get a web server running.
So basically, you're just navigating in your machine.
Yeah. And now, I can figure out my IP address, and I can give you my IP address. So try accessing 129.107.119.155.
So that part is completely
So
free, right?
he's getting, and that's kind of it. So we saw that he was able to access this website from his computer, knowing the IP address. But the thing is, this isn't easy all the time. So it worked now, but it may not work. And one of the reasons for failure is a firewall, which might be blocking this connection, or sometimes there is something called network address translation going on. That is, you're behind a router, which you have to configure first. And over here, so right now I'm using an Ethernet cable plugged into my laptop. If I was connected on the Wi-Fi, this wouldn't work again, because Wi-Fi is a little insecure. So UTA blocks Wi-Fi devices from being servers, or it blocks them from other Wi-Fi devices. That's the thing. It's called Wi-Fi client isolation. So you cannot connect to another Wi-Fi device from one Wi-Fi device. But right now I'm using an Ethernet cable, so it worked out. So what's a firewall? It's a piece of software that blocks connections to ports and computers which are not supposed to be servers. So right now, I mean, he uses his laptop for internet, email, but he's not. Normal people don't run web servers, so they shouldn't be having those ports open. So if anybody tries to access those ports from outside, the firewall will block those attempts. And the reason is open ports are a security risk. Say you had an open, especially in Windows, they have a lot of services, hidden services running, which are listening on ports. And if you don't update your computer, somebody will figure out a way to hack into that service. So that's discussed in the security club. You know, you have different types of attacks you can use to, and most of the time it's buffer overflow attacks. So you specify a string, a specially formatted string, which lets you become the root user and all those things. So anything that's acting as a server but is not being maintained is a big security risk. So many companies will block port 80 on their networks, and even UTA might block port 80 on the net, but it doesn't right now. But if they see your machine running all the time, and they run scans on all the machines at regular intervals. If you look at your server's logs, you'll see a specific UTA machine trying to attack you in different ways to figure out any vulnerabilities. So if they find you have loopholes, they'll block you and things like that. So right now we didn't have to do anything, but sometimes the firewall, the organization's firewall is blocking you, and you cannot do anything about it, and you still want to host a website. So what you can do is you can run your server on a different port. So instead of running it on port 80, I can run it on 8080. The only problem is if somebody tries to access it from their client will send a request to port 80 and they won't get anything back. So I have to tell the person that when you type in my IP address, also specify the port number, excuse me. So you'll have to type in the IP address, then colon 8080. So many times you see that somebody gives you a website address, but they also specify a port at the end. So that's because they're trying to use a non-standard port. So,
but if you don't give the port number, so what is the normal?
The default is 80. If you don't give a port number, it will always try to connect to port 80. And all big web servers, the websites, they are listening on port 80, so it works. But I'm saying in case your port 80 is blocked, so what can you do? You can start a server at a different port, but you'll have to tell everybody to connect to you at that different port. So to make this change, you can go to the Apache config file.
And another constraint is that the service should not be hidden as well, right?
And that's the only option. So Apache config files are in this folder, etc apache 2.
What is this folder for?
For storing the config files for the web server. So I'm not going to do anything. I'll just show you that in this folder there is a file called ports.conf, and it has a line called listen 80. So it means when the server runs, it'll listen, it'll run continuously and listen at port 80. I can change it to a different number, and the server will start listening at that port. You have to restart the server for changes to take effect, but it works like that. And also in this file, so it clearly says also change the port number in this file. So once you make those changes and restart the server, it will start listening at a different port. But right now we don't have to do it because UTA is not blocking port 80 yet on my computer. So Shift F5.
What do you mean by static? I'm not CS.
So I'm saying that I didn't go into installation of PHP in MySQL. So a dynamic website is something where so yeah, the content is generated on the fly. So they might access different news sources, grab that data and generate a fresh page. Every time you go to the website, it'll generate a fresh page for you. In static websites, you have to get into the HTML code, make a new site and then upload it, and then that file will be served. But for a dynamic site, it just it's like a scripted site.
Okay, yeah, I think I see.
Yeah. Any
Yeah,
all
the big
these are
ones,
dynamic
yeah.
sites.
any big site will be a dynamic site. Why isn't it starting? Okay. So another thing is network address translation. So this comes into play because most ISPs, they'll give you one IP address. So you have an internet connection at home, that connection gets one public IP address. But in your network you have 5 or 6 devices. You have your laptop, your desktop, your tablet, your phone, you have your friend's laptop. So all of them are using the same public IP address, and they might be accessing the same website, but somehow all this works. So this is because the router does something called network address translation. So because you cannot get, so every device connected to the internet needs to have an IP address, but you cannot have a valid public IP address because the ISP gave you just one address. You cannot have the same address for all those guys. So the router will assign a random IP address, you could say, from one of these ranges. So if you are connected to your home Wi-Fi and you look at your IP address, you'll see something like this: 192.168.1.5. So that's a local IP address. So what happens is now each machine will get a private local IP address of this form, and when you're trying to access a website from your computer, again a random port is picked at the client. That request first goes to the router and then to google.com at port 80, right? But what happens is the router it doesn't use the same port number. It assigns another random port number that's available and then sends the request to google.com. Because say you have another machine which also opens connection to google.com, and in this example it uses a different port. But what if it used the same port again? What if this also happened to use port 2700? Then it will be a conflict. So the router, every time it receives a request, it changes the source port number to something else, and then sends a new request. And this is my public IP address. This is what it looks like, right? This is a normal address, IP address, and this is something for things inside the LAN. So this is a network address translation. And on the server, so a web server, it gets millions of requests from different IP addresses, but in this case it's the same IP address sending me multiple requests. So but the server is able to look at the source port number because the router used different port numbers for both connections. So it knows these are two separate connections, and even on it uses things like cookies to differentiate between computers and all that. But main thing is because of the unique source port number, it's able to serve different stuff to different. So if you're accessing this page, it'll give you this page. If that guy is accessing a different page, they'll get the different page. So when the request is coming back, So google.com will send your response from its port 80 back to the router's public IP address, because google.com never sees your private IP address. It only sees the public IP address of the router and the source port. So it will send back a response to the same exact port, a different response to the different port. And when the router receives those packets, it looks at the port number, and then it has a table which says that this port was assigned to this IP address when it accessed information from this port. So it takes that information coming on this external port to this machine's port 2700. So every time you make an outgoing connection, so this mapping is saved by the computer. So port 2357 external maps to this machine, this port, and later on it looks up that information and sends it to the correct machine. Now all major routers, they also have a firewall built in, because we see that it's doing so much. It's taking all the packets in, and then it's changing the packets and sending them. So the router has full control over what's coming in and what's going out. So most routers, by default, when you buy them, they have the firewall turned on. So which means they'll block any unsolicited input in incoming packets. So and usually the outgoing connections are not limited, because that's not a security issue. If you're trying to send something, that's not a security issue. But if somebody is trying to connect to you, that might be a hacker trying to get in. So by default, they are designed to block anything that's not in the NAT table. So if somebody tries to connect to port 80 on your computer, that won't be on the NAT table. So it will block that request, right? Because you're not running the web server. But say if you are running a web server on port 80 and you want web people to connect to you and see your website, you will have to do something called port forwarding. So again, this just says that you cannot have random incoming connections. So to be able to serve a website, you have to enable port forwarding, and this option is available on almost all routers. So what will happen is, on the external port 80 of the router, any traffic that comes in, you can make the router send it to a particular local IP address. So for example, my machine 1 with this local IP address, I'm running a web server like I'm doing on my laptop right now. Apache 2 is running and it's listening on port 80. So anything that's coming on the external IP on port 80 gets forwarded to this local machine at this IP. So this allows it to act as a server. Even though it's behind a firewall router, it's still able to do web servicing. And again, outgoing connections are never blocked, so it will always be able to reply. So that's all going to work out. And the router keeps track of everything. The connection is coming through this port, and it keeps track of everything. And for this port forwarding stuff, there is a website called portforward.com. So say you bought a new router and you are doing this web server thing, so you want to figure out how can I enable port forwarding. You can go to this website, and they have a list of all major router brands.